Just start by saying you hear me okay? We've got a new 5-year project that's just started, funded by GRDC, being a national project. Obviously we're working on Blackleg, but as a change we're putting a much larger focus also into sclerotinia, and really for the first time in Australia, up until the last 30 or 40 years, we've really just funded Blackleg research. We're now starting to look at a few other diseases as well for the first time, which is great. So that's where we're going to start today, is looking at other diseases and then move back onto the more traditional ones. This is probably the most common disease of canola in Australia, white leaf spot. It occurs every year and plasters over our lower leaves each year. Last year, as I've put up there, was incredibly severe, certainly the most severe I've ever seen it. And being a fungal disease, I think it was pretty much because we had so many days of constant leaf wetness that the disease just progressed far further than it normally would. Now, all it does is reduce a bit of photosynthetic material, so it's quite visual, but doesn't normally cause much yield loss or many problems. You can tell it's different than Blackleg because it's just these white lesions with no fruiting bodies in them. And the other defining feature is, you can see here, it tends to grow across the leaf and it gets stuck on the veins in the midroof, so you get these quite clear lines. So in a normal year, this is what you'd normally see on an older canola leaf. In the middle of winter, you've got your traditional Blackleg lesion there with the fruiting bodies in it, then you've got a bit of a white leaf spot and maybe a bit of downy mildew, you've got that complex going, but you can see it's quite different to Blackleg. This is what we saw in 2013. That's about the normal infection you see in a normal year. Last year we saw obviously leaves being colonised and then the actual infections moving up the canopy. You can see these plants actually are starting to elongate slightly and the infections move right up the canopy. And then those newly emerging leaves are actually quite colonised, actually starting to die. So certainly in some situations last year, I've no doubt that white leaf spot would have been causing some yield loss, which is, as I said, very rare. At this stage in the project, we're really just trying to determine what diseases are out there and how severe they are. So it's our monitoring work last year. These are a series of NVT trials where we've got extra plots zone to monitor different diseases. And this is the incidence of disease across those sites. So you can see it was quite sporadic across Victoria. In some sites, 100% of the plants were infected. In other sites, very small numbers were affected. Again, it seems to be quite paddock specific. So you can see there Hamilton and Streatham, which are obviously quite close together, very large differences in disease. So there's not much we can tell you about the diseases yet, but over the life of the project, hopefully we'll get some more useful information. This slide here was a trial at Diggera, which we actually set up to look at Foliar fungicide or Prosaro application for blackleg control. And when we got there to do look at leaf lesions for Blackleg, we noted that it had a remarkable effect at controlling white leaf spot also. So the scale here is 0 to 4, visual scores, 0 being no infection, 4 being the leaf being killed. And these are different cultivars. And you can see a very similar pattern across all the cultivars and quite a significant reduction in the amount of white leaf spot. So I'm not going out advocating to use Prosaro to control white leaf spot, but it was just interesting that by controlling Blackleg with the foliar fungicide, in this situation you did get an added benefit by actually controlling white leaf spot also. Next disease is Alternaria. Alternaria pretty much disappeared for 10 years during the drought, but over the last few years it's certainly made a comeback. Alternaria causes these lesions basically right across all the plant parts of a canola plant, but we really only worry about it when it occurs on the pods. You get these black lesions, and the reason we worry about it when it's on the pods is because it does this and causes the pods to prematurely shatter and you lose your seed. That's the main issue with Alternaria. That photo there is from the Hamilton site, and you can see a lot of, or most pods were affected. Again here, it's the same sites where we assess them for Alternaria. Again, 0 being no infection, 4 being most pods infected. And again, that Hamilton site was being severely affected, in this case so was Streatham. So it's the higher rainfall sites. Some work Kurt did a couple of years ago when there was a lot of Alternaria in New South Wales, took the Alternaria affected pods and just planted the seeds out, and he did a number of paddocks and found that of the seed lots he did, the germination varied from 56 to 89%. So that's the other issue with Alternaria, that A, you get the pods infected, you get the shattering, but B, the seed from Alternaria affected plants can't be retained for sowing next year. It will cause seeding. It will A, reduce the germination percentage, but it will also cause seeding blight. So main message coming out of this season, if you did have clients with Alternaria last year, or make sure they source fresh seed that's not affected for sowing this year. Powdery mildew, I didn't actually see any in the field this year. These photos were from my shade house in Horsham, but there were a couple of reports of powdery mildew, so I already just put this slide in there so you know what it looks like. Again, we can't tell you much about it, and it wouldn't normally cause yield loss. So that's really the other diseases. So last year Alternaria and white leaf spot. Now he's going to look at some work that we're doing with sclerotinia. Now obviously sclerotinia was very prevalent last year and caused a lot of yield loss. So it was great that we started this project last year, because normally when you start work on a different disease you never actually see it again. But Kurt got some fantastic data last year. The two issues with sclerotinia are that in Australia, in canola, it's very sporadic. So in many regions it never occurs at all. In some regions it might occur 2 years out of 3, in other regions 1 year out of 5. And the other thing is it's very expensive to control. So if you're getting sclerotinia 1 year in 5, how do you know? And you have to basically put the chemical on before you see the symptoms. It becomes very problematic on knowing whether to go and spend your money or not. The way sclerotinia works is you have sclerotia, which are the way the pathogen survives in the soil. These sclerotia in the soil, they germinate and produce these little mushrooms which throw out spores. The spores land on the petals, infect the petals, and then when the petals get washed off with rain, they land in the leaf axil and cause the stem rot. Now the issue that we have is that this part of the disease basically occurs in most regions every year, but that obviously causes no yield loss whatsoever. The yield loss causing part of the disease, the stem rot, only occurs when you have warm temperatures, high humidity and rainfall all occurring at the same time. And this only occurs very sporadically. So these are photos Kurt got last year. Here's the little apothecia, the little mushrooms germinating in the soil. You can see on this projector, but there's the sclerotia which have germinated and formed the little mushrooms. There's a petal fall from a rainfall event. Petals have got stuck in the leaf axil there, and you can see the infection coming out to the leaf. And then you get this white mycelium growth on the stem, and then you get total plant death. And then the little sclerotia form inside the stem when you break it open, and then that survives for the next year or the year after, or whenever the next infection process occurs. So one of the things Kurt did last year was looked at monitoring sites, and he's just drawn this map here about these in certainly Eastern Australia. This is the region where they're starting to see sclerotinia, which is commonly in 3 years out of 5 or whatever it is, or 1 year out of 5, causing significant yield loss. So it certainly comes into northeastern Victoria. So really our sclerotinia project's got two aims. Basically to give farmers some more advice on how to control the disease. The first one is to produce a predictive model. So the idea will be that we can come up and say that if a certain amount of rainfall occurs on a certain date, a certain humidity, and your crop is at a certain flowering stage, well then there's a very high probability of the disease developing, and we can put out alerts saying go and spray your paddock. So rather than giving you nothing, the idea is that in years to come, a bit like a downy mildew for the grape growers, something like that, we could put out an alert saying that these conditions have occurred in this particular region, there's a higher probability of sclerotinia infection occurring, and then you can make your decisions whether you go and spray or not. And if you don't get that alert, obviously you can save your money. The second thing we're doing for the first time is actually quantifying how much yield loss it occurs, so that when you do get a sclerotinia infection, you can quickly go through your paddock and work out whether it would have been worth spraying or not, and actually do some sums and some economics for future years. So 2013, the program involved, as I said, monitoring crops of sclerotinia development. Kurt had data loggers all over the place, measuring humidity, temperature, and then he also monitored the crops to see how much infection occurred, to try and relate the two together. And this is the data that Kurt has been generating. So from the literature, Kurt identified you need 100% humidity for Sclerotinia to develop. And in his data here at this site at How Long, he found there was 2 instances during, this is the flowering period here, there were 2 instances where 100% humidity occurred, and they also occurred with rainfall, which literature suggests is also very important because that's the bit that washes the petals off and gets them stuck in the leaf axil. So from that, he's identified 2 infection events, and this is the amount of plants, the percentage of plants with a stem rot. And you can see up here it's ended up about 50% of plants with a stem rot. This site here at Morven, again there's been 2 infection events, but this time instead of being sort of 5 days at 100% humidity, the time at 100% humidity was a lot less. There's the flowering period, and he's ended up with about 30% of the plants with stem rot. And then he's got the example here at Cootamundra where, yeah, we did get 100% humidity, but it didn't line up with the rainfall event, and we've ended up with about 5% of plants with the stem rot. So this is the data Kurt's using. These are the things he's trying to identify, and look, it's pretty exciting that we think there was some real potential there, that we could have real live weather going across all the regions, and when the data lines up like that and the crop's in flower, we could easily put out an alert and say, now there's a reasonable probability of Sclerotinia occurring. Whereas if you go to some situation like that, we could say, no, don't worry about it, save your money. The other part of the project, like I said, was looking at how much yield loss is occurring through Sclerotinia. Now, this work's not finished, but before next year we'll be able to give you some information on how to assess it. But these here are 3 different paddocks which Kurt's monitored. The first column here is for plants which have got no Sclerotinia infection. There's the percentage of healthy pods, so 100% healthy pods. This is the percentage of healthy pods for plants which have got a stem rot, so the actual main stem has got the infection on it. And this is the percentage of healthy pods for plants where it was the stem's healthy but the branches are infected. And you've got the same pattern occurring in all 3 sites. So what this basically shows is that it's the stem infection rather than the branch infection which is causing the yield loss. And this is very important when you're looking at timing of fungicide applications, etc. So that's the data Kurt's got at the moment, but he is going to write this to actually yield loss percentage. So the idea will be next or at the end of this year, if you do have a Sclerotinia infection, you can walk through your crop, you can count 100 plants, you count how many have got a stem infection or a branch infection, and then hopefully convert it back to some sort of yield loss figure, and then you could have worked out your economics and whether you should have sprayed, etc. or not. So, warning signs for Sclerotinia. The first point is to get Sclerotinia, you've got to have, in your region, you know, reliable spring rainfall during flowering. The other interesting thing is, certainly in New South Wales, the frequency of canola rotation seems to be a driving factor, that it's the canola wheat rotations which are seeing more disease than anywhere else. The thing that I really think is important for Victoria is that most of Victoria we really don't see Sclerotinia. We see 1 or 2 plants every now and then, but we don't really see any of that yield loss situations like they do in Western Australia and southern New South Wales. So my advice is that really as a starting point, when you're considering Sclerotinia, have you had Sclerotinia in those paddocks in the past? And if you haven't, it's probably not going to occur. So my theory is in Victoria, when we get the wet conditions during flowering is associated with cold fronts and the weather's just too cold for the Sclerotinia to occur, because it needs to be something like 20, 22 degrees, I think, for that Sclerotinia to occur, and we just don't get that warm weather with the rainfall like they do in New South Wales. So that's the main thing. If you've had Sclerotinia in the past, fine, take it seriously. If you haven't, probably don't worry too much. So if you did have Sclerotinia in 2014, what should we do this year? First thing is make sure you're not sowing sclerotia. So those little black resting bodies from the fungus will get stuck in the seed. So make sure that the seed you're sowing doesn't have the disease in it. As much as you can, separate this year's crop away from last year's canola paddock. Rotate crops. The cereals obviously don't get Sclerotinia. It's only broadleaf crops that get Sclerotinia. The other one we've got here is follow recommended sowing dates. The reason for that is we have seen Sclerotinia in some regions where people have sown extremely late for some reason, and then they're flowering further into the spring when the weather conditions are warmer. So that can certainly be a problem. At the moment, our control is foliar fungicides, which can be extremely effective. So this is actually advice from Canada, and these photos from Canada, that they have shown that the best time to spray is at the 20 to 30% flowering, so that's actually very early in the crop. And Kurt, for the last 2 years, has been doing foliar fungicide trials and shown that's also the case in Australia. And we now, from Kurt's work, he's shown that it's the early infection in the flowering period which causes the stem rot. And if you remember back a couple of slides ago, the stem rot's the one that's driving the yield loss. So a lot of the farmers or advisors have been saying, well, let's wait off on our spraying and see if we can protect more flowers as the crops get into flowering. You actually want to come in quite early if you're going to spray and really get the chemical to penetrate into the canopy and protect the main stem, which is where the main yield loss is occurring. So that's pretty much what that slide says there. And obviously, you've got to do the economics on it. What's the potential yield of the crop? Have I seen the disease in the past? How much yield loss has occurred in the past, etc. So that's basically the summary on what we'd call the other diseases of canola. And now we're getting into the blackleg. So just a quick summary of what occurred last year in Victoria. Last year, actually, levels of blackleg were surprisingly low. And the reason for that, I believe, is because we had a very, very dry start to the season. In Horsham, it was something like the driest record for the last 7 months, I think, until we got the break. And we do a lot of work at Horsham where we actually use the blackleg spores for particular experiments, and we found we couldn't get any spores out of the stubble until July. So basically, because it was so dry, the reproduction didn't occur on the stubble, and the spores weren't released. So that gives the plants the opportunity to be sown and germinate and get through the seeding stage before the spores are released. And we know that it's the early infection, it's the infection that occurs on the seedling which will cause the stem canker in a mature plant. So if your plant can get through this seedling stage with no infection, it really doesn't get any stem canker at the end of the year. So basically last year we saw a lot of disease escape. In Victoria or in southern Australia, we've got these blackleg monitoring sites which are co-located with MVT trials. And at each of these sites, we've got sown each of the 7 blackleg resistance groups, and we monitor each of those groups at each site. Basically, we use the information for determining if resistance is being overcome against any of our resistance genes, and obviously give the advice out to the growers and advisors. So to collect that data, we simply pull the plants out of the ground and cut them at the crown, which is where the canker on the plant occurs. Obviously, if the plant's dying or if you can see a physical canker there, it's very easy to say you've got a blackleg problem, but many plants will look very clean like this when you cut them. Just as an aside, Ground Cover TV have produced a YouTube clip on how to assess plants for blackleg. So yeah, advise you go on there to have a look. And this is what you see when you cut your plants open. They're either totally clean, that's what we want to see, or they've got various levels of disease, and obviously disease can get very bad. So on a plant that looks perfectly healthy, you can cut it open and see this amount of disease inside. And as a rule of thumb, we suggest you get about 50% of the internal infection before the yield loss starts to occur. So if you're cutting your plants open, they're all looking like this, that's great, your crop's doing well, you're not getting too much yield loss. Obviously, if they're looking like this, you want to change your management practices to reduce the amount of disease you've got. The other way to use this data is if you've grown a very good resistant cultivar and all your plants look like this, and 3 years later they start to look like that, that's an indication that the resistance is being overcome, and then you want to switch to a different resistance source to go back to that. Because if you keep growing that in the 4th or 5th year, all your plants will start looking like this and you'll get major yield loss. So the blackleg monitoring last year, here's our, for each site, here's our different blackleg resistance groups which contain cultivars with different resistance genes. You can see in most sites in Victoria, compared to the national average, we had very low levels of disease, and disease really wasn't an issue. However, in the northeast of Victoria, we've got a couple of sites there which had quite significant levels of disease. And I guess the main point from this is this point down here, that at the Yarrawonga site we saw the Group D cultivar with high levels of disease. So that's the first time we've seen it in Victoria. Group D until now has been immune to blackleg. On the Eyre Peninsula, where we saw Group D, and I'll go on to the next slide, this is what happened to Group Ds on the Eyre Peninsula in 2011. The crops looked fine, but when we cut them open, we found that they had some disease inside, and we put out a warning saying we think that the Group D resistance was being overcome, and in 2012 there's the Group D resistance being totally overcome. So that's basically the warning now for northeast Victoria, that if you have been growing Group D cultivars extensively, basically don't grow them next to Group D cultivars stubble from last year, or consider changing to a different group. That advice, we produced the fact sheet for each of our monitoring sites, which has got all that advice in there. Now that advice is PDFs and it's available on the NVT online website, so you can get that off for each of those sites and see what's going on in your region. We still recommend that you cut it on your farm so you know exactly what's going on in your farm. However, you can use this regional information as well. So that's basically, I guess, our traditional Blackleg work that we do. This is some other work that we did this year for the first time. These are some photos sent in from South Australia. Over the last 3 or 4 years, we've seen more and more Blackleg occurring not only in the stem of the plant, but actually up in the canopy of the plants. Whether it's just environmental causes or something else, we're not sure at this stage. But these are the sort of things we've seen. We've seen flowers starting to die and then being totally colonised by the disease. And then we've come back in later year and we can see this necrosis causing on the stem where the pods have gone in. And then we've seen this sort of effect here where all the pods have actually been killed. So the flowers have been affected and they never went on to form any pods at all. We've also, this is a pod that's been infected with a nice lesion there. And you can see that the main issue with here is A, it's affecting the seed, but B, it's causing the pod to split as well. So it's a bit like Alternaria where you'll get premature shattering. Again, more of these lesions occurring up in the canopy, which we really didn't see a few years ago. And you see the pods have totally been decimated, and we've even seen instances where the top of the plant's basically missed, so we've got a canker right up in the canopy, which is a little bit of a concern. So, but I guess to bring all this back into perspective, we spent a fair bit of time actually monitoring what was going on in all our monitoring sites. Here's our different resistance groups here, and this is the percentage of pods on each plant which had at least one lesion. And you can see across Victoria that there was lesions at all sites on the pods. However, they're all very, very, very low levels of infection. Conniva was the only one that was a bit of a concern there, with up to about 15% of pods in the Group C cultivar with lesions, which would, I suggest, certainly be causing some yield loss. But to put that back in perspective, here's what we saw on the Eyre Peninsula, where we've got over 40% of the pods there with lesions, and that would be causing considerable yield loss. Just to relate that back to stem canker, at our Conniva site, obviously the grower's doing a pretty good job with Blackleg because the levels of internal infection in the stem are very low. There would be no yield loss from Blackleg there at all, but unfortunately for them, they've copped this foliar disease and are getting some yield loss there from their pods. On Eyre Peninsula, this looks high, but if you look at that, it's about 20% internal infection. As I said before, you need about 50% internal infection to start getting yield loss. So even on the Eyre Peninsula, the Group D's obviously been overcome, but for these other sources of resistance, they're doing a pretty good job, but they're getting a lot of this pod infection. So it is a concern. It's something we're looking at, but I think you need to keep this in mind that at most sites it's still very low levels, and it's undoubtedly associated with rainfall events, etc., during the pod development. This is a photo of what we've done here. Is we've taken a pod with a Blackleg lesion on it, and we've put the seeds out on an agar plate in the same order, and then we've marked where the lesion was on the pod, just to see what happens to those seeds which are from an infected pod. And we got a perfect correlation that wherever the seeds were under a lesion, they were totally affected with Blackleg. The other seeds were perfectly okay. Where we've then taken that same pod and looked at the germination, those infected seeds just don't germinate. So the pathogen's killing the seeds. And then when we did put the other remaining seeds in this case in the glasshouse and grew them out, we've got a seeding blight as well. So story for you guys to tell your growers, I guess, is that if you do get Blackleg lesions on your pods, that you want to find another source of seed, because A, you will get reduced germination, and B, you may get some seedling blight as well. And that's exactly the same story with Alternaria. Now, one of the things I keep getting asked is, what happens if I put jockey on that seed? Will it protect it? I don't know, but we're going to do some experiments over the next couple of weeks. So probably in a month's time, if you contact me, we'll be able to give you some answers on that, whether you can protect it with a fungicide or not. So just in summing up the pod infection story, it's not correlated with stem canker. It's not controlled by Prosaro. So in our foliar fungicide trials, we didn't see any effects there. It absolutely results in seed infection and causes pod abortion and pod shatter. The great news is that if you've got a cultivar with major gene resistance, that resistance will totally control the pods. So if you, in fact, I meant to say, sorry, I'll just zoom back to here. If you look at the different groups here, you can see groups D, E and G had no pod infection at all. And that's basically because they've got a major gene which stops the leaf lesion occurring and also stops the lesion occurring on the pods. Whereas the cultivars, which are more reliant on adult plant type resistance, can get the pod infection as well. Okay. So just going into more routine stuff now, the 2014 Blackleg resistance ratings should be available next month. However, we do have some good news. For the last couple of years, all the MVT entries have come into our screening system 2 years prior to commercialisation. So from this year onwards, we have 2 years of data. So obviously, we can now put out the Blackleg ratings basically 12 months earlier than we did in the past. So when you're looking at new NVT lines this year in the spring field days, they will already have a Blackleg rating and resistance group. You don't have to wait until the March when you've already bought the seed to get the rating. You'll be able to actually, the rating will still occur in March, but it will occur 12 months before the cultivar is released. So that obviously will be very useful. And that will be for the Blackleg resistance groups as well. So basically, just finish off the talk here. Where to get Blackleg data. We've obviously got our traditional sources, GRDC website, the management guide and ratings and groups that will be on there. NVT website will have all our monitoring data on there. But we're also involved in a GRDC pilot project called e-extension, where we're trying to get involved in lots of other things. So we've set up a Google Plus page. Does anyone here have any idea what Google Plus is? We've got a couple, we've got Prue who's running the project. So I would like to think, so you can sign up for Google Plus very easily by just going on Google and then search for our website, and we're going to start putting all our information up during the year. And when the site, not my site, but when the project site goes live, there will be ways that you can type in, ask a question, etc., stuff like that. So basically, we're going to start using, we've got a Facebook page too, which has got our information on it, and we'll Twitter. So when the new Blackleg ratings come out, we'll Twitter that they're available, etc. And we plan to basically use a lot of this information to tell people what's going on during the season. If we're seeing a particular disease in a particular region or whatever, or something interesting is happening, we plan to put that information out. So I'd suggest, if you want to, you can follow us. The other thing we my team were thinking about, we do get asked to do a lot of talks to agronomist groups, etc., which we're very happy to do, but it does get very taxing on travel. So we're basically going to put it out there. If anyone wants to do a webinar or whatever, anything like that with us, that we will make ourselves available, just let us know. And we can help you set up your computer, whatever, so you can do it. I think it's just a way that, if we can give an hour time to have a discussion with some agronomists, and we don't have to spend 4 hours in the car to do it, it'll be fantastic. So if you're interested, just give us an email and let us know, and we'll try and arrange that for you.